In previous videos we talked about exponents, general exponents, and some examples. In this video I want to drill square roots in particular because they show up so much. Now before we get into this stuff, whatever we do with square roots, I want you guys to understand that you could do some of the same stuff with cube roots and other powers. It doesn't just have to be the half power known as the square root. Okay, so you can apply this to other stuff. So today we're going to work mainly on simplifying. So what is that about? So a lot of you know if you have 2/4, you can simplify to a half. The way I like to think about simplifying and why it's important is you don't want to be the guy that walks into a store with $5 and paid in pennies. Don't be a jerk. Simplify. Alright, so there's sort of two concepts to help you guys do some of these. The first one is something I like to use, but you don't have to, so if you don't like it, don't use it. And that's the idea of jail. We'll discuss what that's about. Alright, so what is the square root? The square root is a half power. So if you see the square root of 5, that is the same as saying 5 to the 1/2 power. These are the same. We can also write it this way. The second root of 5 is also known as the square root, but this is so popular we just drop the 2. If you want to indicate that it's a cube root, you have to specifically or explicitly write the 3 or whatever root you want to take. But for the second root, we just write it this way. So what do you get? What do you have to do when you have pretty large numbers? This is not simplified. So let's first discuss these simple cases and then we'll go to some of these more advanced ones. So what is 50? 50 turns out to be 25 times 2. Now if you had done the prime factorization, you would have seen that it's 5 squared, 2 times 5 squared, which is the same as that. So if the number is really ugly and large, you can actually break it entirely down. But if it's sort of easy to see, you might not have to do this, and you just want to find what's the largest perfect square, which is 25, that goes into 50. So if you see this, then you can break up your 50 into 25 times 2. Now, one of the things you're allowed to do with square roots is break one square root, such as this, which is a times b, into 2 square roots. So in other words, you can split this into square root of 25 times the square root of 2. So why do we want to do that? Because the square root of 25 is 5. And the square root of 2 is ugly, it's just the square root of 2, so we just leave it like that. And in fact, because this stuff appears so often, we'll just drop this little dot for the times. So you'll see the 5 written right next to the square root. So that means 5 times the square root of 2. So you might not see the multiplication. So in other words, if you see this, you're not done. You want to leave it in this form. So let's go to 1,000. For 1,000, you can do the prime factorization tree, or you could see what's the largest perfect square that fits into 1,000, and maybe a lot of you see that it's 100 times 10. So the 100 is a perfect square, so you can split this into 2 square roots, and the square root of 100 is 10. So your final answer would be 10 times the square root of 10, or it's also read as 10 root 10. That's the short way of saying it, 10 root 10. Okay, let's try this one. So what we're doing here is the same as before. So 27, maybe you see that 9 is a large perfect square that goes into 27. And so the square root of 9 is 3. And the 3 is left over. Where do we get this? Because it's 9 times 3, and the square root of 9 is a 3. 512. So for this, you might want to do the prime factorization tree and find that this part is 2 to the 9th power. So this is an example of when you might actually want to find the prime factorization and not try to guess what large perfect square goes into it. And as you've seen, that will be this problem, which we'll go into next. So the square root is a half power. So these are the two concepts. So a half power means that this is 16 literally to the 1/2 power. So this is saying what times itself 2 times gets you 16, so that would be 4. 4 times itself, 4 squared, is 16. So another way of thinking about this is related to the concept of jail. And we will see that later on. I've been alluding to it. Let's do this problem first and see how to properly do this and how to improperly do this. So many people will see this and do, or you can also see this written as this way. Whether the square is on the inside or the outside doesn't matter. The effect will be the same. So a lot of kids will see, or students will see this and do this. While this may appear fine, this is a very bad habit. I highly discourage people from doing this, because when you see stuff like this, you might be tempted to square this number first. So if you're doing that, you're doing a lot of extra work. So I don't want to see you guys doing this. I want to see you guys doing it this way, where you say, well, that's a half power and that's a square. So this is really saying 4 squared, but then it's to the half. So these, if you remember the exponent rules, a power to a power you multiply, so you just get 1. So the way I like to think about it, I don't usually write all this stuff out. This is just so you guys can see it. I think of it that the square root is a half power, which is sort of going down, and the square is going up. So these two cancel each other out, so you're just left with the 4. So if you see something like this, these two just cancel each other out, and you just have 57. So don't bother squaring the 57. All right. And now we get to the concept of jail. So why am I introducing this? I think of a square root as kind of like being in jail. If you're in jail, you may have, well, let me put it this way. If you have some item outside of jail, it may not be very valuable, but because the jails are pretty deprived, if you have that item in jail, suddenly it's really in demand. So if you have 2 to the 8th in jail, then outside of jail, it's worth only half of its value. Specifically, so we applied this half power to the 8, so we literally did this. So the 8 times a half, because it's a power to a power, gets you 4. So you could think of it as exponent rules, or you could think of it as like a jail, whatever works for you guys. So when the power is even, this works out really nicely. You just basically have the power. However, we could do this and just say this is 2 to the 9 over 2, or 2 to the 4.5 power, but that's really ugly and it's not considered nice form. So what we do instead is find the largest even power that's under 9, so we would do it this way. And now this part pops out nicely, and this part doesn't. So this part stays under. Now I haven't written a sign, this is multiplication. So in other words, 4 was, if you double it, you get 8, which is just under 9, so that pops out perfectly, and you have that 9th 2 left inside. So for odd powers, the odd power, that last number stays inside. So let's try this one. You could have more stuff going on. So for this one, it says 2 to the 10th times 3 to the 13th. So what's going to pop out? If there's 2 to the 10th, so there's 10 2's multiplied inside, when they pop out of jail, there's only 5 2's. So they're not worth as much outside of jail. Now there's 13 of these, so 12 is the highest even number under 13. We have that to pop outside of the square root, and we get 6. Because 6 doubled is 12, just under 13. And that 13th 3 stays inside because it was an odd power. So that would be simplified form. So if you see this, don't leave it like this. You want to leave it like this. Why? That's just convention. All right. Let's go to this one. Now in this 5th problem, we have stuff on the inside and stuff on the outside. So the way it works, let's take a simpler example. If you have 2 times the square root of 2, we can't really bring any more 2's outside because there's only 1 2 in here. So we can, but if we have a lot of 2's in general, so let's make this a larger problem. So let's say there's 2 to the 4th, 2 to the 5th, 2 to the 6th, let's say. we could pop the 6 out and turn it into a 3 because we're having it, and turn this into that. So the 6 contributed to 3, and then these would combine using exponent rules and give us a 7. Now, for some reason, and in some cases, you might want to do the opposite. You might want to bring this inside, and you have to remember, if you're going inside, then this 4 is suddenly more valuable. It's now an 8. Because now when you apply the half power to the 8, it has to turn back into a 4. And so now you would get 2 to the 14th on the inside. It's 2 to the 7th on the outside, right? These make a half of 14 is 7. So you can go in or out, doesn't matter, but when we're simplifying, we want to take everything out as much as we can. So to do this problem, we already have this on the outside. 11, we can pop, well, 10 is the highest even number, so we pop 5 out. One of the 2's stays in, that's that 11th 2. If it's 3 to the 40th, we can pop out 23s, that halves perfectly. So this is almost simplified, and then you would combine your 2's and your 3's. So the 2's get you 2 to the 9th, and the 3's are 23 times the square root of 2. So that would be your final answer for number 5. All right. Number 6 is another variation you might see where you're not given the prime factorization, but it's some wacky large exponents of composite or non-prime numbers. So here, there's 2 ways of doing this. The first method is use this idea right away and say, okay, since there's 31 on the inside, 30 is the highest even number under it, so we can pop 15 out. And we have 1 8 left inside. And then you could say, well, an 8 itself is not simplified. That's a 4 times 2. So this is really square root of 4 times the square root of 2. And square root of 4 is 2. So that 4 turned into this 2. That stayed, and that stayed. Now you could leave it this way, or you could now try to break this 8 down into 2's itself. So this is 2 cubed. And there's 15, so we carry that over. And since a power to a power is 45, then we have another 2, that's 46. So that's one way of doing it. It works, but it's kind of clunky, so maybe you don't want to apply this right away. The alternate way of doing it is saying, let's break the 8 down first and then apply the square root. So this would be the square root of 2 cubed to the 31st, which would be square root of 2 to the 93rd. So now you say, okay, so therefore it's 2 to the 46, because 46 doubled is 92, just under 93, and that 2 is left inside. They're both good methods. I probably slightly prefer this method. All right, I'll leave it there for now. In the next video, we'll discuss some other operations, some normal operations like addition, subtraction, and other operations we can do with square roots.